right, well, welcome to class. What I need you to do is get out your workbooks, start working on the warm up here. I have some things to look at. There are three things that I would like you to graph, and then I'd like you to write an equation. So I'd like you to graph y equals negative 2/3 x minus 4. I'd like you to graph y minus 2 equals 3/5 times the quantity x plus 1. I'd like you to graph 4x minus 2y equals to 8. And then write an equation when the slope is negative 1/3 and you have a given point negative 3 comma 2. So again, this should be a review. You're using all three forms we've learned so far. You have the slope intercept, the point slope, and standard form, and all three ways to get the graph. So go ahead and work on that. I'll give you some time to do that now while the sub takes roll. All right. Well, let's go through this really quick. It is review for everything, so I'm going to fly through this. So y is equal to negative 2/3 x minus 4. This is the slope intercept form. So it gives me the slope and it gives me the y-intercept. So if I'm going to graph this, I go down 4. That gives me the y-intercept. And then I go down 2 and over 3. So by doing that, I'm able to connect the dots. Now remember, label your x and y axis. Label your x and y axis here. So this is the graph. And remember to put the arrows that this keeps going on forever. So your line should include the arrows. Next up, I'm going to do y minus 2 is equal to 3/5 times the quantity x plus 1. So this is the point slope. So again, I'm given the information of a point, which remember you take the inverse. So negative 1 comma 2. And the slope is 3/5. So if I start with the point 1, negative 1 on the x, 2 on the y, that gives me my starting point, and then I go up 3 over 5, and this gives me my line. Remember to add the arrows. Remember to add the arrows so that you're showing that it keeps going on forever. All right, next up, 4x minus 2y is equal to 8. So remember, in standard form, you're really looking for the x and y axis, or sorry, the x and y intercepts. And so you're going to solve this twice. Once when x is equal to 0 and once when y is equal to 0. So this should be reviewed for everybody. So I want to know what happens when x is 0, what happens when y is 0, because those are going to give me my intercept points. So if I plug in, substitute 0 for x, that cancels out. 4 times 0 is 0, so I have negative 2y is equal to 8. Divide by negative 2. I get y is equal to negative 4. So I have an ordered pair point on the coordinate plane where x is 0 and y is negative 4. And over here, when I have 4x minus 2 times 0, because y is 0, so this cancels out. I get 4x is equal to 8. Divide both sides by 4. So I get x is equal to 2. So again, those two pieces will give me the coordinate point 2, 0. So these 2 points, so 0, I don't go anywhere on the x-axis, but I go down 4. That gives me my y-intercept. The x is 2. That gives me my x-intercept. And I have my line labeling my coordinates, x comma y, my x-axis, y-axis, and then the arrows on the line that it keeps going on forever. All right, last up. The slope is equal to negative 1/3. Write that a little nicer. And I have the point -3, comma 2. So I'm going to use the point slope form here to write an equation because it's given me a point and a slope. So by substituting in that information, I get y minus 2 is equal to -1/3 times quantity x plus 3. Remember, you take the inverse. So y minus 2 is equal to -1/3 times quantity x plus 3. All right, great job. And if you have any questions, I'll be able to answer those when we get back. When I get back. All right. So what I'm going to do now is today what we're going to review from Algebra 1, and it's a very key concept here in Algebra 2 that we have to make sure is I'm going to review the standard form again. And I need to really understand the concept of substituting in the x and y when they're 0. So let's cover this. So if I have -3x minus 5y is equal to 15. Just like we did in the warm-up, if we have x is equal to 0 and y is equal to 0, then that produces an ordered pair for 2 points. All right, so if we plug in x equal to 0, y should be -3. And if y is equal to 0, x should be -5. Right, so these produce points. But here's my question: is what happens if you just have x or y in your equation? There's not both of them, just one of them. So what happens? So in standard form, we were able to conquer that. But what happens if there's no x? So let me give you an example. 2y is equal to 4. So if 2y is equal to 4, notice we don't have an x value here. But I can solve for y. So if I divide both sides by 2, I get y is equal to 2. Well, if we go back to what we've done so far in class these 2 weeks is understanding the concept that when I ask you to graph something, you're really just justifying to me a picture of what the solutions are. So if I were to ask you, where are the points on a coordinate plane where y is equal to 2? So where is y equal to +2? Well, I know that if a line crosses the x or the y-axis at +2, that's 1. But where is it where the y value is always +2? So I could think of a lot of points. And I'm starting to get this picture that looks something like a horizontal line. Because on a horizontal line, the y value is some set number and it never changes. So you're justifying to me, hey, there's a coordinate plane, x and y, where if you were to draw a picture of every spot on that graph where y was equal to 2, but you have no x value, that means that the line never crosses x. Because if you don't have an x value, that means it never intersects with the x. All right. So what does this look like if we have an x value? So what if we have 3x is equal to 9? I can solve for x by dividing by 3, and I get x equal to negative 3. So again, if I were to represent that pictorially as a picture, is there some point on the line where x is negative 3? Well, I know that would be a point. I know that would be a point. That would be a point. I'm starting to get all these points where the x value would be negative 3. And I'm starting to get this picture of a vertical line. So this is where horizontal and vertical lines come from, is when you don't have a y value. Y value is not set. It could really be anything you want. Then your only controlled variable is your x. You're going to get a vertical line. Now, the inverse of that statement is true. If you know that the change is going to be based on y is equal to 2, but x could really be anything, then you're going to have a horizontal line. All right, so let's start making some connections here. Let's go back to the slope-intercept form, y equals mx plus b. And I want to identify the slope. Well, if I have something that starts in this form, and I end up with something where y equals some number, I'll leave it as b. My question is, what happened to the x? And again, remember, we've chosen the origin a lot for testing. And the reason why I said it's nice to choose for testing is because 0 makes things go away. So what would have caused that x to go away? The only thing that could do that is if it multiplied by 0. So if you have y equals some number, that number would be the same from this formula, but you could write it as a different way. Let's expand that out. 0x plus b, some number. Then we know the slope would be 0. So remember, the y gives us a horizontal line. So if we have y equal to some number, this is a horizontal line. This is where your slope is 0. And we just proved that using the slope-intercept form. So we took slope-intercept form and compared it to a horizontal line. Well, the only thing that's going to make that true is if the slope was equal to 0. But here's where we run into a problem, is what if we have x equal to something? X equal to some number is a vertical line. So let's break this one down. I'm going to go back to this one right here where x is equal to negative 3. So the slope, you told me last week, you remembered from algebra, you remembered that the slope was the rise over the run. So no matter what the rise is, it could go up 3, down 7. That number is going to be set based on example x equal to -3. Your y value could be anything, and it's still going to have an x equal to some number. But what would the run part? Where do you go on that line, left or right? I'll give you time to think about that. If you have a vertical line, where is it running to if it had a slope? And the answer is nothing. It's not going anywhere, which means it's 0. And if you have any number over 0, by definition, that's undefined. You can never divide something by 0. It's undefined. It's a mathematical term that we call undefined. So you're not, anytime you have a vertical line, you don't have a slope. The slope is undefined. So let's go back over to here. The vertical line, your slope is undefined. All right. So those are things you either need to extrapolate yourself based on the graphs or just memorize them. Anytime you have a horizontal line, your slope is 0. Anytime you have a vertical line, you're undefined. And I always think about it in how a slope works. And I reference it into driving a car. So if you're driving uphill, I'll put a red line uphill. If you're driving uphill on that red line, you're going up. You have a positive slope. So from left to right, this is a positive slope. And my green line, if I'm driving downhill, I have a negative slope. And if I'm driving on the freeway on a flat road, a horizontal line, my slope is 0. I'll do that in a different color, blue. But if I drove on a car, if I drove on a car with a road that looked like that, I would be undefined because I'd die. So I always remember slopes as in how I drive in a car. If from left to right I'm going up, my slope is positive, I'm increasing. If I'm in a car and I'm going down, I have a negative slope because I'm decreasing. If I'm driving on a flat line, I'm not going up or down, my slope is 0. But if I were to drive straight off a cliff, straight down, I would be undefined. They'd have to put me in the ground. So that's how I remember slopes. Okay? All right, so what I would like you to do is I would like you to now practice graphing some horizontal and vertical lines. So I'm going to give you some time to work on this. And what I would like you to do is graph these two lines. One of them is going to be a vertical line, one's going to be a horizontal line. And what I want you to do is identify the slope as well. Okay? So refer back to your notes. Take some time. Go ahead and work on those now. All right, welcome back. All right, so what I'm going to do is I'm going to solve for y. So I have negative 4y is equal to 20. Divide by negative 4. So y is equal to negative 5. Where is that true? Where is my y value negative 5? Well, I know that's one point. I know that's another point. Well, I have at least 2 points so I can connect the line. So this is my line, y is equal to negative 5, and my slope is 0. Over here, I need to divide both sides by 2. So x is equal to 13 halves, which is 6.5. All right, so I go over 1, 2, 3, 4, 5, 6, 7, right in between there. And the x is there and there, all 13 halves. So now I have a vertical line where x is equal to 13 halves. And my slope is undefined. Because remember, if I drive off in a car on that road, I'm going to be undefined. Okay, so this is a vertical line. This is a vertical line, and this is a horizontal line. So here's my question to you. Here's my question. What would change if you replace the equals with an inequality? What if you replace an equals with an inequality? Remember from yesterday's lesson, we're going to treat inequalities the same exact way as equations, except for one thing. And if you remember that from the last lesson, if you multiply or divide by a negative number, you're going to switch the signs. Remember, keep that scale in balance. If you multiply or divide by negative, you just change that scale. You're going to have to invert the inequality. So what I'd like to do is I would like you to regraph these with an inequality in their place. Now be careful because I have one is equal to and one does not have an equal to. So you're gonna have to remember from the last lesson what happens. So go ahead and take some time and do that. All right, welcome back. What we need to do is divide both sides by -4, just like before. So my question to you, if we treat equations and inequalities the same, except for when we multiply divide by negative, did I just do that rule that I need to be aware of? And the answer is yes. I just divided by negative, so I need to switch the sign, need to invert that. So instead of y is greater than or equal to -5, I have y is less than or equal to -5. Over here, x is less than 13/2. So what we need to do is graph these two inequalities now. Remember, in graphing inequalities, we treat them just like their equivalent sibling, the equation, except for we have to keep in mind whether or not it's a solid or dotted line. So go ahead and share with your tables. What is a solid line? What gets a solid line? What gets a dotted line? You got 30 seconds. Go. All right. So if you discussed at your tables, if you include an equal sign, it gets a solid line, and if there is no equal sign in the inequality, then it has a dotted line. So on this one, we know from doing the equation part, where is y equal to -5? We get a horizontal line at -5. And we know it's going to be a solid line because it's less than or equal to. So remember, for testing purposes, we're going to test the origin 0, 0. So in the origin, the y value is 0. So is 0 less than or equal to -5? The answer is no. So therefore, we need to shade the other side. So these are where the y values are less than -5. So anything in that area up to the line and including the line. So let's go over to this other inequality. 13/2 is 6.5. So I have a dotted line that is vertical at 6.5. And then I'm going to choose the origin 0. Is 0 less than 6.5? The answer is yes. So then we shade that correct side. But remember, it's any point in that area, the x value is less than 13/2, but not including that vertical line. All right. All right, so now what we're going to do is I'm going to give you time to practice this on your own. So I would like you to graph -5y is greater than or equal to 35. And I would like you to graph when -2x is less than 10. Ready? Go. All right, welcome back. So we're going to treat this just like an equation. So we're going to divide both sides by 5, negative 5. So I need to flip the inequality because I divided or multiplied by a negative number. So y is less than or equal to negative 7. If I graph this, whereas y is less than negative 7, so I have 1, 2, 3, 4, 5, 6, 7. I know that that point is. So I have a solid line because it includes the equals. And let's test 0, 0. Is 0 less than negative 7? The answer is no. So therefore, you have to shade the other side of the origin, that line, the other side of the line that the origin is on, because then that means the other side must be true. All right, let's do this other one. Actually, we need to solve for it first. So negative 2x is less than 10. Divide by negative 2. I'm multiplying and dividing by negative, so I need to switch the sign here. So x is less than negative 5. Nope, x is greater than negative 5. I said you need to switch it, and I didn't switch it. X is greater than negative 5. So where is that true? So what we need to do is graph that. All right, so let's graph this. X is greater than negative 5. I have to go 1, 2, 3, 4, 5. That point is. So I have a dotted line, a dotted vertical line at x is equal to negative 5. So I need to test the origin. Is 0 greater than negative 5? The answer is yes. So I need to shade the origin side of the line, but not including the line. All right, great job today. Go ahead and pack up your notebooks. And if you have a few minutes, go ahead and take out your phone, check your text messages, but do not congregate by the door. I hope you have a great day.